Okay, let's go. Practice test. Number 1. I don't know. Determine whether the relation is a function. Justify your answer with mathematical reasoning. This is from section 3.1 in your ebook if you need to review it. How can you determine if something is a function or not a function? Yes. Yes, so let's check. Input of 1 has an output of 9. Input of 2, output 11. Input of 2, output of 13. Is that a function? Not a function. Not a function. Input of 2 has 2 outputs. Next one. Determine if the function is linear or nonlinear and justify with mathematical reasoning. Would this equation be linear or nonlinear? This equation is linear. Plane x's and y's. What would make it nonlinear? What would be in an equation if it's nonlinear? Nonlinear would have what? Give me something a nonlinear would have.
Parentheses.
A little bit more. A linear could have parentheses.
Like those straight lines, like the distance from 0.
Yes, bars, absolute value bars. So nonlinear could have absolute value bars or exponents. But this one's linear. Question? Okay. Number 3. Determine the domain and range of the function represented by the graph. This is a function. Is this discrete or continuous? Is this discrete or continuous? Discrete. Because it's just a bunch of dots or points. But DD. So the domain for a discrete function is you just list the values. List. So what's my first x value? 1. My next x value is a 2. My next x value is a 3. My next x value is a 4. Then a 5, then 6. That is my domain. Domain, remember, are your x's. Ranges are your y's. So your y values, what's the smallest y value we have? -1. Next y value, 0. 1, 2, 3, and then it jumps up to 6. So you list your x values, list your y values. That's how you do domain and range. Are there any questions on that? Okay. I didn't use the inequality symbols because I don't have points in between the other points. I just have one set of points. Number 4, domain. So domain is your x. You want to look left to right. So when I go left to right on this, do I have any endpoints going left, or will it keep going? It keeps going because of the arrow. Do I have any endpoints going right, or does it keep going? Keeps going. So my domain is all reals. My range, or my y values, I have to look up and down with your eyeballs. When I look up and down, I see I have a point here at -2, and then I have points above that. So how do I write that I have y values at or above negative 2. It does look like there's an open circle too. Let's call that an open. So if that's an open circle, how do I say that this is, I have points here and above? Yep.
Negative 2 is less than 1.
You're right. Or y is greater than negative 2. Either way. Good job. You have y values. Here, I'll write that out. Y values above y equals negative 2. Any questions? Okay. Next. Number 5. Evaluate the function f of x equals 4x minus 2 for the given value of x. Here's f of 6. Is this an input or an output? Is it in the parentheses or outside of the parentheses? In. This is your input, which means that means x is 6. So you're just going to do 4 times 6 minus 2. You're putting 6 into the function. 4 times 6 minus 2 is 24, take away 2, which is 22. F of 0. That means when x equals 0. 4 times 0 minus 2. 0 take away 2 is negative 2. F of negative 5. That's when x equals negative 5, because that's your input. It's inside the parentheses. 4 times negative 5, take away 2. Negative 20, take away 2 is negative 22. Any questions on those? Given the function g of x equals 5x plus 1, find the value of x in which g of x equals 31. Are they giving you an input or an output? An output, right. This is on the outside. So therefore this is the output. So you are going to do 31 equals 5x plus 1. Find x. Makes sense that you have to go find x since the problem is asking you to go find x. So you're going to solve this little equation for x. Minus 1. 30 equals 5x. So x equals 6. Any questions? Next, given the graph below, find the value of x when f of x equals 4. Is 4 an input or an output? Is it in the parentheses or outside? That's an output. Output. So the output, that means when y is equal to 4. Remember, that's the whole reason why we started using f of x. F of x is the same as y. So we look on the y-axis. Here's when y equals 4. This is the line y equals 4. What does the function equal? What does x equal when y is 4? What's this x value when y is 4? That is your answer. X equals 3. So x equals 3 when y equals 4. Any questions? Try the next one. Same thing, when y equals 4. Here's when y equals 4. Yep. Well, this is y equals 4. What is the x value when y equals 4? X equals 0 is your answer. So that's your answer. Okay, good job. Next page. Find the x and y intercepts of the graph of the linear equation 3x minus 6y equals 24. X-intercept. That is when y equals 0. So you'll do 3 times x minus 6 times 0 equals 24. So 6 times 0 is nothing or gone, or 3x equals 24, x equals 8. Your x-intercept, therefore, is 8 comma 0. X, y. X is 8 when y is 0. That's your x-intercept. I'm just going to draw a line to separate the two. The y-intercept is when x equals 0. So 3 times 0, I'm plugging 0 in for x into that equation. 3 times 0 is gone. I get negative 6y equals 24. Y equals negative 4, because negative 6 times negative 4 gives you positive 24. Your y-intercept then is 0, negative 4. X is 0, y. Any questions? 11. Determine the slope of the line that passes through the points 4, 8, and 4, 9. I strongly recommend making a table. Make table. 4, 8. Notice where I put 4, 8. 4 is an x, 8 is a y. 4, 9 is my next point. 4 is an x, 9 is the y. To find slope, you want to do change in y over change in x. So we look, what's my change in y values? How do I go from an 8 to a 9? I add 1. So my change in y is up 1. My change in x, how do I go from a 4 to a 4? Is there any change there? No change. My change in x is 0. 1 divided by 0, or 1 over 0. Who knows what the slope would be for this problem? Not 0. This is remember I did no, can't have a 0 in the denominator. This one is an undefined slope. Undefined slope. What kind of line has an undefined slope? Vertical. And even look at the points, 4, 8, and 4, 9. If you were to graph those, 4, 8, 4, 9, notice how they line up in a vertical line. Remember slope dude? Undefined. Number 12, the points represented by the table lie on a line. Find the slope of the line. Again, when you have a table, just find your change in y over change in x. What is your change in y values in this table? How do I go from a 40 to a 50 to a 60 to a 70 to an 80? Add 10, add 10, add 10, add 10. So your change in y is a 10. My change in x, 2 to 4, 4 to 6, 6 to 8, 8 to 10. What's that pattern? Up 2, up 2, up 2, up 2. And we always reduce. Ten over 2 reduces to 5 over 1, or just 5. The slope is 5. Next, 13 through 15, rewrite each in slope-intercept form, which is y equals mx plus b, and then graph. So I'm going to circle 6y, because that's what I want to get by itself. You want to isolate the y. Minus 3x, minus 3x. So I get 6y equals negative 3x. I'm going to write minus 12. Divide everything by 6. So I've isolated y. I get y equals, always reduce, negative 3 over 6 reduces to negative 1/2 x. And negative 12 divided by 6 is minus 2. So I've rewritten this so that it's in y equals mx plus b form, which that's what I wanted to do. My b is negative 2, so on the y-axis, that is my starting point at negative 2. From that negative 2, I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. Now it's a negative slope, so that's why I went in that direction. And then I create the line with arrows. Negative slope. Questions? I'm trying to get this by itself. That minus sign belongs to the 3. So I'm subtracting 2x to both sides. Negative 3y. That minus sign keeps with the 3. Equals negative 2x plus 15. We always put our constant term last. Divide everything by a negative 3. So we've isolated y. Now always just reduce. A negative over a negative becomes a positive 2/3 x. And 15 divided by negative 3 becomes minus 5. So now it's in y equals mx plus b, which is exactly what I wanted it to be in. So I can start at negative 5. 1, 2, 3, 4, 5. And up to over 3. 1, 2, 1, 2, 3. I could go down to 1, 2, 3. Either way you go, notice how I've created a positive sloped line. And it was a positive slope in my equation. Notice how right here is where I started. The negative 5 is my y-intercept. So careful on that. Number 15, x plus y equals 6. Get y alone. Just subtract x to both sides. Y equals negative x plus 6. Now this is in y equals mx plus b. My b is 6. 1, 2, 3, 4, 5, 6. My slope, this negative sign, that means it's negative 1 over 1. We don't write a 1 or a negative 1 in math. We write just this sign. So up 1 over 1, down 1 over 1. Notice how this is a negative slope. Questions? Okay, next. Number 17. The graph in the table represents the amount of money in a bank account over time, x months. F of x equals 300 minus 25x. Graph the function by making a table of values. So you're going to make a table of values. Now it's always good to start with, when did this data start taking place? When x is 0, 300 minus 25 times 0 would equal 300. So that's your first point. 0, 300. When x is 0, your function is at 300. Let's do when x is 4. Now I'm just picking these values. You just pick some values for x. 300 minus 25 times 4. What's 25 times 4? 100. So 300 minus 100 is 200. So when x is 4, your y is 200. How about 8? 300 minus 25 times 8. So after 8 months, how much money is in the bank account? Well, 8 times 25, that would be 200. 300 take away 200 is 100. When will you have no money in the account? How many months? 12. At 12 months, 300 minus 25 times 12 would give you $0. So we could connect this. Now, I'm not going to go any further. So what would the domain be? I'm going to put my domain here. Domain, what's your smallest x value? 0. And your largest x value is 12. So your domain is x is anywhere between 0 and 12. That's your domain. The range, the lowest y value you have is 0. The largest y value you have is 300. So your range is anything in between 0 and 300. While we're talking about it here, I just want to take note. This point here would be 0, 300. That's your y-intercept. And this point here, that's 12, 0, that's an x-intercept. Just good to know. Good to know. How much money is in the account after 4 months? Oh, we already did that in the table. When x is 4, your output is $200. When will the account have no money? Oh, we did that too. Good. 12 months. Because 300 minus 25 times 12, 300 minus 300 equals $0. Okay. Absolute value functions is on your test tomorrow. H and K is your vertex, so that's something you need to remember. And A is the slope of each ray. So in this problem, HK, x minus h, x minus 4, that means h is 4, k is 3. So plot the point 4, 3. 1, 2, 3, 4, 1, 2, 3. That is your vertex. Now in this equation, this number in front, that's A. And A is the slope of each ray. Because it's negative, that means it's open down. So A being a negative 2 means negative 2 over 1, down 2 over 1, down 2 over 1. Do both sides to create that V-shaped graph. That is something you need to know. You need to know that an absolute value function will create a V. Number 19, HK. Now in this problem, because of the plus 2, that means H is negative 2. K is negative 3. Negative 2, negative 3 is located right there. Now the A being 1/2, that's your slope. It'll go up 1 over 2, up 1 over 2, both sides, to create the V-shaped graph. Number 20, write the equation of the graph below and determine domain and range. This function is an absolute value function. So, important pieces you want to determine. Vertex point. What is this vertex point? This vertex point is 3, negative 2. So that's giving you the H, and it's giving you the K. So you can pop that in to this problem or function. The only thing missing is the A. So you have to determine what the slope is of each ray. So from here, I could go up 2 over 1 to find each point. So that means my A is 2. And there's your function. Domain. So left to right, there's no endpoints. That's all real numbers. Range. The lowest point is at negative 2, and then it's above that, so y is greater than or equal to negative 2. Last page. Piecewise. So remember, piecewise functions, you want to graph the line. So you're going to graph y equals 3x. So let's just lightly graph that whole line, starting here, up 3, over 1, over 1, down 3, over 1, 1, 2, 3, over 1. So that's the whole line, y equals 3x. We don't want the whole line, y equals 3x. I only want this piece. When the x's are less than 0. So here's my x-axis. Here's 0. So I'm going to have an open circle here. And less than 0 is to the left of 0. So I'm going to keep this piece. And I don't need this piece. And then you do the other line. Y equals x plus 4. Graph that line. Oops. 1, 2, 3, 4. Up 1 over 1. So that's the whole line, but I don't want that whole line. I only want this piece. When the x's are greater than or equal to 0. That's to the right. So this is when x is 0, to the right of 0. And then I erase this side. Next, 22. So this one incorporates an absolute value function. How do I know that that's an absolute value function? Absolute value function should be a V-shaped graph, so you definitely need to know that. Now for this function, the vertex is where? The vertex for this one is 0, 0, because there's nothing inside and nothing outside. So you're going to start at 0, 0. And A, when nothing's in the front, that means A is 1. So you go up 1 over 1, up 1 over 1, both sides. It's up to you to know that this will make a V-shaped graph. Now we don't want the whole function, we only want when the x's are between -5 and 2. So 1, 2, 3, 4, 5, 1, 2. That's when x is -5 and 2. So that's here and then here. So you want everything between there. Oops. And then I can erase all this. I don't need that. Then lastly, y equals -3. That's a horizontal line. So 1, 2, 3. That's y equals -3. I only want when the x's are between 2 and 6. 3, 4, 5, 6. So that's here. And then open circle here.